Good morning. This week we are going to look at the periodic table, which is basically just a chart that organizes all of the elements that we know into some kind of cohesive and easy to understand way. In 1869, a Russian chemist, Dmitry Mendeleev, created the framework for what would become our modern periodic table, that which you can see before you. He actually left gaps when he created and started to organize this for elements that had not yet been discovered, but he kind of assumed what existed in some way, shape, or form based on how he organized that periodic table. While he arranged the elements according to their atomic weight, if he found that they did not fit into the group, he would rearrange them, and he would predict the properties of some of those undiscovered elements and gave them names. Even though some of his predictions were not actually accurate, once we learned more about some of the elements as we moved forward or discovered more elements, his ideas and his organization, again, is going to be the framework for what we now know about the periodic table.
All right, so let's look at what we can tell about the periodic table. Look at how it's organized and some things that the way it's organized can tell us about particular elements. We're going to start with looking at horizontal rows. So let's going this way. So hydrogen and helium, right, would be one horizontal row. This would be another horizontal row. These horizontal rows are called periods. And there are 7 periods. We label them 1, 2, 3, 4, 5, 6, and 7. So this would be going that way, going this way. And periods can tell us really important information because each element, depending on what period it is, its period tells you how many shells there are. So for instance, hydrogen has 1 electron shell. Okay. Lithium, beryllium, they have 2 electron shells. Oxygen has 2 electron shells. So remember when we went back to that other lecture video about how electrons are organized, here's the nucleus, and then you had a shell here, right? And then N equaled 1. So this would be helium and hydrogen, or helium and hydrogen. Then you had another shell, then you had another, and we only really diagrammed 4, but know that there are a total of 7 shells. So the periods can tell us how many shells are in an electron. And these are our horizontal rows. Now let's look at going up and down. Going up and down in columns, we call these groups. Okay, so groups are vertical rows, and these are going to be important because they're going to be organized based on the number of valence electrons. Now there are 2 ways that we label row or groups on a periodic table. The first way is just like periods going all the way across. So this would be group 1, this would be group 2, this is group 3, group 4, group 5, 6, 7, 8, and this is how they're labeled on your periodic table. And there's 18 groups, right? So there's 7 rows, there's 18 groups. Now, we also are going to kind of sublabel these groups in a different way that's going to indicate the number of valence electrons. So I should have maybe written that in green. But I'll show you how that would be. So this would be 1A, this would be 2A, then we would go all the way across. We're basically going to skip this whole middle section of these transition metals. We'll talk about that in a second. So this would be 3A, 4A, 5A, 6A, 7A, 8A. So by looking at, like, for instance, 1A has 1 valence electron. 7A has 7 valence electrons. And these we would actually, they do these again, but they would do B. So this would be 3B, 4B, 5B, 6B, 7B. And you will have to write these ones in because they are not written on your periodic table. 11b and 12b. Okay, so periods go across, groups go down. So again, if we kind of just draw this down here, that is a group. Groups and periods. Now, we also are going to organize the periodic table into basically 3 different categories. We have metals, and that's going to be these categories here. Then we have the metalloids, and then we have the nonmetals. These 3 categories are going to have very distinct characteristics. So obviously metals are going to be shiny, they're going to conduct electricity. Nonmetals are going to be the opposite. They're going to be really dull. They're not going to conduct electricity. And metalloids are actually kind of in between. So if we look here at the metals, we can draw a line right here. That is going to mean everything over here is going to be a metal. Here, we draw another line. These are where the metalloids are going to be. And you can kind of see how they're colored on your diagram, right? So the metalloids would be right up here. And then these then on this side, so let's go right here, these would be the nonmetals. So you will also notice that we have these 2 rows down here, right? The lanthanides and the actinides. These are going to be, they're separate, in part because it makes it easier just to see the periodic table by removing them, but also because they have a completely different electron configuration than the other elements. So they're kind of separated out into this bunch here. And we're not going to spend a lot of time talking about those ones, but just so you understand why they've kind of been moved out. Now, among the nonmetals, and I'm sorry, I should have included these 2 in the nonmetals as well. We are going to, in the metals, let's start with the metals. So in this row here, we have the alkali metals. Okay, so it's color coordinated. In this row, we have the alkaline earth metals. Then all of these in yellow are called the transition metals. And then you have these in green that are called basic metals. Sometimes they're also called post-transitional metals. All right. So all of these different categories are going to have certain characteristics about them. Then you have your metalloids. And then over here we have the halogens, which are in group 7A. And then you have the noble gases, which are right here. Now, the noble gases are really important because noble gases are the most stable element. And the reason is because they have a full outer shell of valence electrons. They have 8 in their outer shell. And so this is going to make them very stable. They do not react with any other element because they don't need to. All these other elements outside of the noble gases are either trying to pick up electrons, give up electrons, or share electrons in order to make their outer shell equal to 8. Next week, we're going to talk a lot more about these noble gases, and I'll show you some electron configurations that show you how these all end up with 8, even though they have a wide range of different numbers of protons. I should say, we talked about this way back in week 1, but, these are all going to be organized based on their atomic numbers. So, right, going from left to right. So here's 1. Hydrogen has 1 proton, 2, and then 3, then 4, and 5, then 6, and 7. So they're also going to be arranged based on the number of protons that they have. So you can tell a lot about the electrons that each element has based on where they are. You can tell characteristics about them. Are they going to be shiny? Are they going to conduct electricity? You can tell how many electron shells there are based on how many periods there are. There's all kinds of things that you can tell just based on where an element is on the periodic table. There's one other important trend that you can tell, or characteristic you can tell about an element or an atom just by looking at the periodic table, and that is the size of the atom. Okay, so the size of an atom as you go down is going to increase. So size increases as you move down the periods. Now this should make a ton of sense to you, right? Because this only has one electron shell. This one has got 7, right? So it's got 7 going all the way around. So you know that this size is going to be bigger. Size also decreases as you move across the periodic table. And as we'll talk about more next week, the reason is because we're actually going to be adding electrons, which is going to be attracted as we move across. We add more electrons, which is going to be attracted to the protons that are in the nutrients or the nucleus, and it, opposites attract, so it's going to actually pull everything a little bit closer and tighter together because of that attraction. So as you move across, the size is actually going to decrease. So you can tell the size of an atom just based on where it is on the periodic table. So for instance, on a test, if I said, is this atom bigger than this atom? Well, you'd say, well, as you go across, the size decreases. So this one has to be smaller than this one. Okay. If I said, is this atom smaller than this atom? Well, you know that this, as you go down, right, it gets bigger. So you would say, yes, this atom is smaller and this one is larger. And there are test questions like that. So just from the periodic table, we learn how many protons there are, right? And that's just looking at the atomic number. We know that they're arranged from left to right. So 1 proton, 2 protons, 3, 4, 5, 6, 7. We know how many electrons there are, right, based on the number of protons. We know how many electron shells there are based on the period number, 1 shell, 2 shell, 3 shells, 4, 5, 6, 7. We know we can get a general idea about some characteristics because metals are going to be shiny and conduct electricity. Metalloids are going to be kind of half metal, half not metal, and then the nonmetals are going to be dull and non-conductive. We know that there are characteristics and groupings, subgroupings of metals, subgroupings of the nonmetals. Halogens is a subgroup, and noble gases are the most stable of all of the elements because they have a full set of valence electrons. So they have 8 valence electrons, which we know from looking up here at these numbers. So this group has 7 valence electrons, this group has 6 valence electrons, this one has 5. And this will kind of make a little bit more sense, like I said, next week when we start talking about how does an element decide if it's going to give up an electron, pick up an electron, or share an electron. And that's all going to be based on the number of these valence electrons, and you're going to be able to use these patterns to help you see and know, hey, oxygen is going to, pick up 2 electrons, right? Over here, lithium is going to give up electron. So we're going to be able to revisit this a little bit. But these are basic trends on the periodic table. If you have questions, please don't hesitate to ask. Have a great week.